Okay, page 3. Okay, my pencil go. So here, it gives you a function, and then it says, is the function increasing or decreasing? So this is I know that a is equal to 1. So a is greater than 0, so it's positive. And b is less than 1, but bigger than 0. So b is in between 0 and 1. So this should be a decay function. It should go like this right here. That should be the shape. This shape is increasing. No, sorry, this shape is not increasing. This shape is decreasing. It is concave up. And the limit as x goes to negative infinity, so the left end behavior, the left end behavior is going to positive infinity, and the right end behavior is approaching 0. It's hard to see that pencil. Oh, be fine. So this next one, once again, a is positive, a is 3, so a is bigger than 0. Should be bigger than 0. And b is bigger than 1. So this is going to be an exponential growth. So this function looks like this. It is always increasing. This one is concave up again. The limit, this is as x goes to negative infinity, so the left-hand limit is approaching 0. And the right-hand limit as x goes to positive infinity, y goes to positive infinity. Okay, h of x. This one, a is negative, so a is less than 0 here. So it's going to be reflected. And b is in between 0 and 1. So this is going to be reflected down from its counterpart. So this is the same here, so this should be reflected down. So this should look like that right there. Now this is increasing. We're going up from left to right. It is concave down. The limit on this side is the left-hand limit as x goes to negative infinity. H of x goes to negative infinity as well. And then on the other side, it's going to be going towards 0. Okay, next up. This one, a is less than 0 again, so a is negative, and b is bigger than 1. So this is going to be a reflection of this one. So we reflect that, and it should look like, kind of ran out of room there, should look like that. So this should be decreasing. It's going down from left to right. It is concave down. And the left-handed limit is 0 as x goes to negative infinity. This should approach 0. And the right-hand limit as x goes to positive infinity. This goes to negative infinity. Why negative infinity? That looks weird. Y goes to negative infinity, where j of x goes to negative infinity. Okay, next up is half-life formulas. So the unstable element in a sample is known to decay by half every 400 years. There is 36 grams of this element at time equals 0. What of the following is an appropriate model for the problem? So as it goes through time itself. So here we know this is going to be exponential decay. This is exponential decay, so these are bad. No addition in exponential decay, so we can't use 1. So it has to be C or D. And we want to know how many half-lives pass. If you remember the half-life formula, great. The half-life formula is essentially just is just your starting value, A times half to the T divided by whatever the half-life is. So this is going to be this one right here. If you don't remember the half-life formula, this exponent, this is how many half-lives have passed, and since one half-life passes every 400 years, this is 400 years to be 1, so 1 half-life after 400 years. This would be, if 400 years passed, this would be 16,000, which is way too big. Okay, here the table of the presents values. Everyone's been really good at these with plugging them into the Desmos calculator. You'll get some formula. This one, I told you guys, make sure you check the log box. Make sure you have that ticked off when you select your exponential function in the calculator. Plug that in, and you should get that number right there. That number right there. Okay, so make sure you know how to do that in Desmos. And I'll see you guys on page 4.